Okay, we've got another A/A star topic here, which is another tough one, and we've got a little bit of formulae to make sure we remember as well. So let's have a look at the curved surface area of a cone. So we've just looked at the surface area of a pyramid. Now we're going to look at the curved surface area. Now it's just a bit going around the middle of our cone. Now what is a cone? A cone is a solid with a circular base, and you make one of these cones by taking out a sector of a circle and then folding it together to create this three-dimensional shape. So we know that the arc length of our sector, I'm going to draw over that in red. When we fold that to make our 3D shape, that arc sector, that becomes our circumference of our cone. Now we should know from earlier on, or looking at the other chapter, that our arc length is theta divided by 360 times by the circumference of the whole circle, which is 2 times pi times r, but notice r here, that's equal to L. Okay. Now we should all notice that L, that becomes our diagonal, our slanted part of our cone. Okay, but let's finish that off in a second, because now we know that the arc length with a radius of L, that is equal to the circumference of this circle with a radius of r. So what have we got here? We've got theta divided by 360 times by 2 pi L, when we look at it that way, is equal to 2 pi r, when we look at it this way. Now if we divide both sides by 2 pi, they will cancel, and so we get left with the formula that r is equal to theta divided by 360 times by L. Now that formula you do have to remember, so it's worth understanding exactly how we got that in the first place. Okay, now the second formula you don't have to remember, so that's good, and that is that the curved surface area of our cone is equal to pi times r times L. So you don't have to remember that one. You'll be given that in the front page of your book. And again, if we wanted to work out the total surface area of our cone, well, that would be the surface area of the curved part given by pi rl plus the surface area of the base, and that's a circle, so that's just pi r squared. So two formulae there, one you don't have to remember and one that you do. Okay, so there's the one you have to remember, there's the one you don't. So let's now use that for a question. We've got our formula at the top of the board there, apart from the one that we do have to remember, so let's write that one down. So that was that r is equal to theta over 360 times by L. Right, okay, so we've got a sector here. Now this sector is folded to form a cone, and we want to find out the radius of the cone to one decimal place. Remember the radius? That's the same as the arc length. Okay, so when we work that one out, we get 300 divided by 360 times that by L, which is 6. Put all that into your calculator and you should get 5. So when we draw our cone, we don't know what L is yet, but we know that this distance here is now 5. Okay, part B says find the curved surface area of our cone. Use the formulae. Curved surface area is pi times r times L. So we get pi times r, which we now know is 5, times by L, which is 6. Okay, so this distance here is 6. That's the bit that's been folded up. Okay, put that into your calculator, and to one decimal place we get 94.2 centimeters squared, because it's area. Okay, now the total surface area of the cone, well, we said that was the curved surface area plus the circle at the bottom. So that'll be pi r squared for the base, so pi times 5 squared, plus the curved surface area, which is 94.2 centimeters squared. Add those two together and we get 172.8 centimeters squared. And finally, we want to try and find out the vertical height of this cone. Okay, so what have we got here? Well, we're trying to find out this length here. Let's call it h. Okay, we know this length here is 5. We know this length here is 6 because this side is 6. So if we want to draw that triangle so we can see it a little bit clearer, we've got a height that we're trying to find out. We've got a base of 5. and we've got a diagonal 6, and this length here, that's my h. So using Pythagoras' theorem again, we get h squared plus 5 squared is equal to 6 squared. That's a squared plus b squared equals c squared. Evaluate those, we get h squared plus 25 is equal to 36, so let's come up here. H must equal 11, h squared must equal 11, and therefore h is equal to the square root of 11, which when you work it out to one decimal place, we get 3.3 centimetres. So lots to take in there. Again, quick recap, this formula you do need to remember. We remember that by understanding that the arc length becomes the circumference of our base of our cone. Then we can just apply these formulae as long as we know these two dimensions, our radius and our length, and we can use those to even be able to find out the height of the cone. Okay, so make sure you can do that, and we'll come back to that later.